mouse trails, and trackers. Whether you think they enhance and create a unique user experience or are completely unnecessary, you can't deny that they look fun to move around. Today, we will be diving into the code that makes all of these effects possible. As said before, I like to define two types of effects in this category. A mouse tracker is an element that is always present on the page and follows the mouse cursor at all times. A mouse trail, on the other hand, is made up of a large number of elements that appear and disappear as the cursor moves around the page. I will show you how both of these are made behind the scenes, but we won't stop there. We will create 6 different projects, each facing a unique problem we will need to solve, and by the end of the video, you will become a master on JavaScript mouse move effects. So let's get started. I will create a main folder for my project, and inside I will dedicate a folder for each of the examples. The examples will only have one HTML file, with the exception of the last example, for which we will need some images. I will place those images inside an image folder next to the HTML file. This will be the simple boilerplate HTML code with which we will start off in every example. Let's begin with the first example, the simple mouse tracker. We won't be writing a lot of HTML today. As you can see here, we only need one element with the class name of tracker, and we can already move on to the CSS code. In the CSS code, we start off by giving the body a background color and some scrolling space. Then we style the tracker, which will be a simple circle, and we give it a fixed position. The reason for this is so that the tracker keeps working even as the page is scrolled. We set the pointer events property to none so that we can still be able to interact and click things without being obstructed by the tracker under our cursor. A really powerful CSS property, if you ask me. And with that, we can move on to the JavaScript code where the real work happens. First, we select our tracker. Then we set up some variables. We get the tracker's width and height. Now we can write the function that will animate the movement of the tracker. We don't want to just assign the tracker's position to be the same as the cursor position. The tracker should lag behind the cursor, and this simple calculation provides just that. You can see that the faster the cursor moves, the bigger the lag of the tracker is. The mouse variables only track the current position of the cursor. Using the position variables as shown make the effect more dynamic, and it looks smoother. Now we need to use these position variables on our tracker. Here we also remove half of the width and height of the tracker in order to have it placed in the center of the cursor. If you don't remove this, the tracker will be placed above the cursor. And if you remove the full size instead of just half, the tracker will be placed below the cursor. Of course, what I'm showing you here is the finished product, so you won't be able to see it yourself just yet. But we are getting there. Now we call the request animation frame built-in JavaScript function, which tells the browser that we want to run an animation and runs a specified function over and over again each frame. We put our animation function here. Then we need to actually set the mouse X and mouse Y variables to the cursor position of each axis. JavaScript has these properties ready for us to use. We update these positions every single time the mouse moves on the screen. And finally, we do an initial call on our animation function, which starts the animation frame loop and animates the tracker at the positions we have specified above. That is one down and 5 more examples to go. In the next one, we will see how we can animate multiple elements like this. Let's switch to the next HTML file located in the Multiple Mouse Trackers folder. This time, we will have a container element for the trackers. I will create 4 trackers, but you can add as many as you wish. The CSS will be almost the same here, with the exception of adding different background colors and sizes for each tracker. In the JavaScript, the mouse variables will be the same, since there is only one cursor. However, we will have multiple trackers this time around, so the variables that apply to them need to be arrays with multiple values now. Each tracker will have its own position that needs to be calculated and animated, and I will also make each one slower than the previous. Since there are multiple trackers, we need to loop through them. Here I will add an object to each position, with the values for positions on both the X and Y axes. In this loop, the tracker parameter represents each of the individual trackers, while the index parameter serves as an ID. A new addition are these target variables, which represent the target each tracker should be following. We are using a ternary operator, which is a small if statement that can be used on one line. We are simply saying that the first tracker should follow the cursor, just as it does in the previous example, but the rest should follow the previous tracker. This creates a snake-like movement that we are aiming for. We apply these target variables in the calculation instead of mouse X and mouse Y like we did in the previous example. You can see the difference between the calculations from the current and previous example here. If we use the same calculation from before and omit the target variables, you can see what it looks like. Not really what we are aiming for, is it? All of the trackers are moving a little slower than the previous, but they are still following the same target. Adding dynamic targets makes the movement more natural, and it simply looks better in my opinion. If your trackers have the same width and height, you can get away by using just one dimension like this. If not, then get the offset width and height as we did before. The rest of the code will be the same. That would be it for example number 2. Pretty cool, right? Now we jump to the file located in the folder named Interactive Mouse Tracker. The code for this example will be mostly the same as in the previous example. The main goal is to create a simple interaction between the mouse tracker by making the tracker disappear when the button is hovered and reappear when the button is hovered off. In the HTML, we will have 2 trackers and we will create a button to interact with. The main difference in the CSS code will be the styles for the button. This transition is added so that the tracker disappears and reappears smoothly. We will create a simple modern button design with a custom border decoration. After adding all of the hover effects, we can move to the JavaScript code. The JavaScript code is pretty much the same as before, so you can easily copy and paste it. Only at the very end will we be adding something new, and it will be quite easy. We simply make the tracker disappear when the mouse enters the button and appear again when the mouse leaves the button. This simple approach is a great way to keep other elements visible as you interact with them on the page, instead of having your view obstructed by the tracker. Now, we have finished example number 3 as well. You can take a look at what you have created. At this point, we have finished all of the tracker examples, and we can start creating our first trail effect. Let's head to the HTML file located in the Simple Mouse Trail folder. Now, this example won't actually have any HTML code whatsoever, so we start with the CSS. The only new thing here will be this animation, which will be added just before the trail elements disappear. You will see it in action very soon. The JavaScript code starts with a mouse move event listener. We want to create a new div element every time the mouse moves and add a class name to it as well. This is the reason we don't have any HTML code. All of it will be created dynamically right here. Now we simply instruct this element to move wherever the cursor position is on the screen at the time of its creation. Then we need to add this element to the page in order for it to show up. Nobody wants a bunch of divs appearing and bloating the page every time they move their mouse. That is why after a second has passed from the creation of the div, we will remove it entirely. Before the element is removed, the animation we made in the CSS will kick in. This will make the div fade out, shrink, and in the end, it will disappear for real. You will notice that we haven't used the request animation frame function for the trail. The reason for this is because there is no movement to animate. This effect is simply a bunch of elements appearing and disappearing one after the other, wherever the mouse moves. This creates an illusion of movement, but nothing really moves. That wraps up this example. Looks neat, doesn't it? The next thing I want to do is control how often these elements are being created. In this simple example, they appear instantly as soon as you move the mouse even a little bit. This does work well here, but it won't look as nice for the next example. So let's move to the Square Mouse Tracker folder and continue our journey. For this example, I will only create a simple hero section with a heading inside. The CSS concepts remain mostly the same. I will set the position of the heading to relative and give it a z-index of 1. We do this in order to have the text in front of the whole mouse move effect. I will also set the pointer events property to none because I don't want the text to interfere with the mouse move effect. In the animation keyframe, apart from fading out, we will also move the square down on the y-axis. This will make it look like the squares are falling down and disappearing. This time around, we will have two additional variables. One defines the time between each square creation, and the other marks the time the previous square was created. This will give us control over how often we want things to appear as the mouse moves. We will also set the values of the square's width and height. And in this array, we add all of the different background colors we want the squares to have. You can add as many as you like because we will apply them randomly for each newly created square. As I said before, I want to be able to control how often a square is created. The first idea you might think of is to make a script that creates a new square only when the mouse has moved a specified distance in any given direction. While this is a viable option, there is another dimension developers often forget, and that dimension is called time. The date.now function gives us the number of milliseconds that have passed since January 1st, 1970. And in the last trail time variable, we hold the number of milliseconds from the last time the mouse was moved. By subtracting the current time from the last time the mouse was moved, we get the time between these two mouse move event triggers. By setting an if statement where this value needs to be greater than the trail interval variable from before, we make sure that a square only gets created after a certain period of mouse movement time. The larger the number you set in the trail interval variable, the longer you need to move the mouse for a square to be created. Now we mostly follow the same steps as before: creating the element, assigning a class name, setting the position on the screen, and so on. In this line, we are setting a random background color from the colors array to each square. And after repeating some more steps we have already learned, the fifth example is finished. Take a look for yourself. Let's move to the final example, where we will replace these colored squares with random images. In this last example, we are pretty much repeating things we have already learned. Of course that there are a few key differences since this example requires images, and I will explain those pieces of code when we get to them. I have set the user drag property to none in order to prevent the user from being able to select and drag images like this. This isn't extremely necessary, but I thought it might be useful to add. By setting the object fit property to cover, we make sure that the image will cover the size we have set it to be without stretching out and deforming to do so. Another very useful CSS property. As you can see, the JavaScript code is very similar to the last example. One of the few differences is that the array of background colors now becomes an array with image file names. Also, we are creating an image element instead of a div. And of course, instead of adding a random background color, we are assigning a random image source to the image element. If you have made it this far, congratulations. You now possess the toolbox for creating fun, interactive mouse trail effects. I hope this video was useful, and you can expand upon this knowledge to create some more amazing and intricate examples. If you wish to gain access to the source code from all of my videos and some more awesome stuff, you can consider becoming a member and directly support the channel. Thank you so much for watching, and I'll see you in the next one.